Okay, welcome back to part 2. We're going to finish looking at the unit circle ones, and then we're going to move to the calculator on the next page. Okay, so we have example number 7 here. Cosecant of beta is undefined. Our domain is from 0 to 2 pi included, but 0 not. Okay, so undefined, good grief. Okay, let's see how that can happen. Undefined happens when you're dividing by 0, right? First of all, you'll notice that it's a cosecant function. So we don't like working with those anyways. Let's switch it to its reciprocal, which is sine. Now, this happens when we're dividing by 0, right? So if we flip or reciprocal something that had been divided by 0, we would now have 0 divided by, we don't know. But 0 divided by something that wasn't 0 is still going to be 0. As long as 0 is on top, it's 0. Okay, so we're basically looking at where sine of our angle was 0. That's what that is all about. So half the battle here is interpreting this to make sure we're working with the right thing to go to the unit circle. Okay, so off to the unit circle. We're looking for where sine, which is y, would be 0. Okay, well that would have to happen at one of the axes, right? So where sine or y is 0 would be here as well as here. Okay, so that means we have our angles, or we're going to get them now, name those angles. Okay, and our domain, if you don't like this way of writing the domain, the interval notation, you can rewrite it like this. So it's a little easier for you to see if you're used to that. Okay, so this first angle normally could be called 0, 2 pi, negative 2 pi, this first angle. We could call it 0, and it is 0, except 0 is not included in our domain, so we're not going to call it 0. Okay, let's keep going from 0 to 2 pi. This angle here then could be called pi, between 0 and 2 pi, and then we keep going all the way around, and we're back to this terminal arm, which could be called 2 pi, and this time 2 pi is included. So we would include 2 pi in our answer. There we go. It has to be within our domain if we're going to name those angles. Okay, let's look at the next one. Cotan of alpha equals 0. Now cotan, yes, is a reciprocal function of tan, but unlike cosecant and secant, we do not have to flip cotan, because tan being y over x, cotan is simply x over y. And it's just as easy to use it as x over y as it is y over x. Okay, and then you'll notice our domain now is in degrees. Keep that in mind when we get to the end. Okay, we have 0 over something, we don't really know, but it doesn't matter because if we have 0 on top, that would tell us that x is 0. Okay, so that's all we need to know, is we need to figure out where x is 0 on our unit circle. So x would be 0 again on an axis, but this time here. Our coordinates there are 0 and 1 and 0 and negative 1. So that's why we're at these locations. Draw those in red so they show up a little more. Okay, now we have to name those angles. We're in degrees. I know you've gotten used to radians now. You're going to want to name it as pi over 2. Well, it's not. It is, but not in degrees. Okay, so we're going from negative 90 included. Okay, so negative 90 would be this way to here. And we do have a terminal arm right at 90. Check your domain. It is included. So we would write that alpha includes negative 90 degrees, okay? And then we continue around until we reach positive 270. Okay, so that's all the way to here. But we do have this terminal arm before we get there, and that in degrees would be 90 degrees. So our two answers are negative 90 degrees and positive 90 degrees. Oh, wait, one more answer. 270 was included all the way around. So that means we also would include 270 degrees because we have a terminal arm at that location. And it's equal to from our domain. Haha, tricky one. Okay, next question, number 9. This is the last one using the unit circle, then we're going to the calculator. Okay, tan squared theta equals 3. So notice the squared, don't let it freak you out, you just have to get rid of it first. So square root both sides. So now we would have tan theta equals, and when we square root both sides, we have a positive and negative possibility of root 3. Okie doke. So these ones tend to be a little bit harder. Tan we know to be, let's write that over here. Tan we know to be y over x. So we don't really have a fraction going on. Let's change that to over 1. Root 3 over 1, still root 3. Okay, root 3 we normally see as root 3 over 2. So if I divide the top by 2, I'm going to divide the bottom by 2. And voila, there we have all of our coordinates. Root 3 over 2, we recognize that one. And 1/2 for x, we recognize that as well. So we're off to the unit circle. Okay, so first of all, tan y over x, where it's plus or minus. Well, that's going to be all 4 quadrants, isn't it, when it's plus and minus? Okay, where y is root 3 over 2, that's the big coordinate, right? 1/2 is the little, remember that from last lesson? So where y is big in this quadrant, we've got these two choices for the big little thing. This one here is where y would be big, okay? And if we use our straight line policy, straight line to the other quadrant, we'll find the other tan, okay? And then we have to be in this quadrant as well, so where y is big would be there. Straight line it down to the other quadrant. And there we go. We have 4 answers. That usually happens when you have a squared. You double the amount of answers that you have with a certain domain. Oh, look at our domain. This is going to be fun. Okay, negative 360 to 360. Alrighty then, this is going to be a lot of answers, start far over. So our domain is really twice what it usually is. Usually it's just once around, this is twice around. Okay, so negative 360 would be going from here to here. So we have to name these angles as negative angles first of all. So from here to here, let me just get rid of that first one. Got rid of my line. Okay, so our first angle is going to be in a negative direction to there. Okay, so we're working in degrees, and that would be like 30 degrees past 270. So that would be negative 300 degrees because we went in the negative direction. All right, next angle would be, let's see if I can erase this without erasing everything. Our next angle would be to this terminal arm. Okay, so that's 30 degrees shy of 270. So 270 minus 30 would be 240, but we're in a negative direction, so negative 240. Okay, now we're down to this angle here, which would be, let's see, that would be negative 90, then another 30 would be negative 120. And then this one here, 90, but not quite, 30 less than that would be negative 60 degrees. Okay, now the positive angles. Same idea, but now we're going positive direction. 60 degrees, 120 degrees, 240 degrees, and 300 degrees. If we go in the positive direction. What a mess. Okay, and there we go. That was fun, wasn't it? Okay, let's look at some other ones on the next page. Okay, so we have now secant x equals negative 1.2631. Yeah, that's not one we know on the unit circle necessarily, is it? So what we're going to be doing is that's when you can use your calculator. All right, so first of all, before we get there, notice we have secant. Okay, if it was cos or sine or tan, we could immediately go to the calculator and do the inverse of the right-hand side. It's not, so we need to flip it like we did with the unit circle. Cos x first, and that means we're reciprocating the right-hand side as well to get that. Okay, how do we find x when it's stuck inside a cos? Guess what? We inverse cos both sides. Okay, so what that means, and that gets rid of this cos. That means we now have x equals the inverse cos of 1 over negative 1.2631. Okay, for those of you wanting to go to your calculator right away, I'm not sure I would suggest that. It's probably a good idea to write this down so you know what you're doing. Okay, so we're going to bring up our calculator and do that. Pause your video. You can try it. I'm going to do it as well. Okay, so you've gone to your calculator and you did this. Now, one of two things are happening here. You either didn't get the same answer as I did, which is okay, um, or you're looking at this answer and you're going, that's kind of a weird number. Considering our domain is from 0 to 360, do you think we have an angle of 2.5 degrees? It's probably not the case. And here's the thing. When every time you go to your calculator and you touch either sine, cos, or tan, you need to check your mode. So if we go to mode, notice I'm in radian. So that means if our domain was given from 0 to 360 degrees, I should really be in degree mode. So I need to go down, go to the right. Where am I? There we go. Hit enter on degree, and now degree is shaded in. Okay, so we second quit out of there, and guess what? I don't have to type this in again. I can just simply hit enter, or have you guys seen this one? I can go second enter, and it types up whatever I just typed in, and I can change it if I wanted to. Okay, so we hit enter, and there we go. Now it's in degrees. So our answer would be, I didn't say nearest to whatever, nearest degree, so let's assume that I want it to the nearest degree, so 142 degrees. All right, so here's the thing. Your calculator is not as smart as you are. Yep, that's true. So you need to figure out, because you know we've been getting two answers for a lot of these, right? 142 degrees, that'd be somewhere over here in quadrant 2, because it's bigger than 90, but not as big as 180. You need to figure out where the other terminal arm is that would give you, and this is how you do it, go back up here, that would give you a cos, which is x, that is negative. So where is x negative? Well, x would be negative in this quadrant and this quadrant. So that means our other terminal arm is a reflection of the first one over the x-axis. And now we're looking for that angle. Okay, now since it was a reflection, we would also know that this angle was 142. So to get this terminal arm, we would go probably all the way around to 360. So go all the way to 360 and then subtract 142. Okay, that's how we're going to get our other answer, which would be 218. Okay, there we go. Okay, so we have our two answers. That looks good, 0 to 360. Awesome. Let's try the next one. And actually, if you guys want to try this one on your own, it's somewhat similar to what we just did. You could pause your video now, and then we could work through it. Okay, so pause your video, give it a try. Okay, so let's see if we got the same answer. So first you would reciprocal cosecant, which would be the reciprocal of sine, and we're going to reciprocal the right-hand side as well. So 1 over 2.45. Then we want to get rid of the sine so that we can get at the x. So we do the inverse sine on both sides. So now we would have x equals the inverse sine of 1 over 2.45. Okay, and you're off to your calculator. And when you go to your calculator, you should end up getting 24 degrees. We're still in degree mode given our domain. And this means we're going from 0 included to our angles now x to 360 degrees. Okay, so we've got 24 degrees. Once again, that's probably not our only answer. So we draw 24 degrees somewhere in the first quadrant, and then we go back and we look at what trig function we had. Well, we had sine, which was y, and it looks like it was positive. Okay, so we go, where else is y positive? Well, that was here in quadrant 1, but also in quadrant 2. So our other answer would be a reflection over the y-axis, which means we are trying to find this angle. And if it's a reflection over the y-axis, if this was 24 degrees, so would this be 24? So to get our other angle, we would go 180 all the way to pi, right, or 180, and subtract 24 degrees. And there we go, we do that, and we would get 156 degrees. And there's our other answer. Okay, let's look at the last one here. Cotan theta equals negative 5 over 4. We'll probably run out of time on this one. So I think what I'll say is we'll do part 3, very short video, and can finish this last example in that. Okay, so we'll see you in part 3.